Hello and welcome to this MicroTasker Shorts video in which I'll be showing you how to build the MicroTasker i.MX RT Loaderand Application with GCC compiler from within Visual Studio. When building the MicroTasker i.MX RT bootloader from within Visual Studio, we have three different projects. We start with the MicroTasker bare minimum project, and we make sure that we choose the target for i.MX RT plus the GCC build. The first thing that I do is I go to the config.h file for the bootloader project and I choose the board which I'd like to build for. I'm going to build for this one here. So I disable any other one which was enabled by default. I then open the make file which is going to be used for building this project. And I do one simple check, and that is to verify whether I have double precision or single precision floating point enabled. This line is for double precision, which is valid for most of the i.MX RT parts. If you happen to have a part with single precision, then this is the line which will be commented in rather than the second one. Now I'm leaving it like this because my 1060 has double precision floating point. The next step is to check my bat file. Now in the bat file, all I have to do is to make sure that the name used matches with the target which I want to build for. Now I can command a rebuild. Now while it's building, I'm browsing to the output directory where the objects created will be located. And we see here that once the build is successfully completed, we have an output binary file called MicroTasker boot, and then with the name of the board which we're building for. Now this binary file will not be used alone, instead it's going to be used as an input to the next step. The next step will be to build the fallback serial loader. So I open up a second Visual Studio project for the MicroTasker serial loader. In the config.h file to this project, I also select the board which I'd like to build for. This is the same board as we built the bare minimum bootloader for, and what I do initially is I activate the fallback serial loader version. Again, I open up my GCC make file to verify that I have the correct processor, and I open up my build bat file and I place my board name into it. Here I have a variable called fallback, and I need to set this variable to 1 because we're building the fallback loader. You will see some other variables here. These match with the project's security settings. And now I build the loader. In the meantime, I browse to the output file location where my objects will be located to. Once the build has completed, I then see that in my output directory I have two files. The first one is called MicroTasker fallback loader image for the target which I built for, .binary, and then there's a hex version which is used mainly by people using Teensys because that's the format that they need to load to their boards. The image contains the bare minimum bootloader which we built in the previous step combined with the fallback serial loader. This could in fact now be loaded to the board. However, I'm going to continue by building the serial loader. Moving back to the MicroTasker serial loader project, I now select the serial loader, which means that it's no longer the fallback loader, so I disable the fallback serial loader define. I move to my bat file and I set a 0 for the fallback variable instead of a 1, so that we now build for the serial loader. Once the build has completed successfully, we find some additional outputs. We find the MicroTasker serial loader upload image, which could be uploaded to the board which has been programmed with the fallback loader. And also we find a complete image which contains the bare minimum bootloader, the fallback loader, and also the serial loader in one single step. Normally the bootloader would only need to be built once, and then it's used for loading the application. So we take a third MicroTasker project in Visual Studio, which is the MicroTasker v1.4 project, and again we select the target that we're building for in config.h. Again, I do my check in the make file to verify that I have the correct processor, and in my build.bat file I select the target name. Now I can build the application. In the meantime, I also browse to the output directory location. Now once the build is completed, I find a number of output files. MicroTasker complete image and then the name of our board binary is a complete image of the bootloaders plus this application. Now this file is useful in a production programming environment because here you program the loader and your initial application in one step. Again, we have an Intel Hex version which is predestined for Teensy 4 users. We then have AES-256 encrypted versions, binary and S-record, which are designed as upload files which then run in the internal RAM. These are followed by plain text versions which are simply unencrypted. And then we have two XIP, that means execute in place versions, which are designed for large projects which do not fit into the internal SRAM, which are then run directly from the QSPI flash on the board. The first one is a plain text version, the second one is an encrypted version. That's why it's got OTF, meaning on the fly. Now, depending on the board which it's being built for, this will already be in the correct format for BEE decryption, that's the bus encryption engine, which most of the i.MX RT parts have, or for the OT FAD, which, for example, the 1011 will have in it instead. So thank you very much for watching this video, which has explained how to very easily build the MicroTasker i.MX RT loader and the application, whereby you automatically get all of the formats which you need for plain code or encrypted code operation.